Here we have a pipe assembly subjected to an 80 Newton force at C. And then we want to find the moment about A. So we want to do the moment equals R from A to C cross with F, and we'll call that F at C. So we want to write the vectors of both of those. So we'll start with RAC. So RAC, let's see here, in the X direction, it goes 300 plus another 250. So let's do meters, so 0.55 in the I direction. And then in the J direction, the Y direction, it goes just to 400. So plus 0.4 in the J. And in the K, it drops 200 right there. So negative 0.2 in the K. Now let's do F. So let's start out with, so F, it's kind of hard to see there, but it looks like F has an angle here in the, we'll call it the XY plane, and then an angle here in the Z direction. So this length right here, that's going to be FZ. And this length here, that's going to be FXY. And then this here is Fx. And this here is Fy. So let's find Fz first. So Fz is going to be 80, and this is sine, so sine 30. And that equals negative, well, 40, but I should have said that's going down, so that's in the negative direction. So negative 40 in the I. So Fxy is this one, so that's going to be equal to 80 cosine 30, and that equals 69.3. So this is 69.3 in that direction. So let's find the y and the x. So Fx is going to be 69.3, and that is right there is going to be the sine of 40. So sine 40 is 44.5, and Fy is going to be 69.3 cosine 40, and that is 53.1. So F is equal to 44, we'll round that up to 45, 45 in the I, plus 53 in the J, we'll cut out the 0.1, minus 40 in the K. Now we'll do our cross product, R cross F. And in the R, we got 0.55, 0.4, negative 0.2, 0.55, 0.4, and F is 45, 53, negative 40, 45, and 53. So here's our positives. 0.4 times negative 40 in the I, plus negative 0.2 times 45 in the J, plus 0.55, 0.53 in the K. And then our negatives, negative 45 times 0.4 in the K, minus 53, negative 0.2 in the I, minus negative 40.55 in the J. Now if we combine the I's, and we get negative 5.4 in the I, the J's, and we get 13 in the J, and the K's, and we get plus 11 in the K.